Hello everyone. In this video I want to talk about the structure of the lungs and talk about the mechanism of ventilation or breathing and how breathing essentially works. It's something that's taught all the way through from key stage 3 all the way up to key stage 5. And this video is really applicable to any of those key stages. Now I've got a diagram here that has been partly labelled but is deliberately missing a few bits. So I'm going to talk about the diagram and then add the few bits in to do with the lung structure and then talk about what essentially they do. So we'll just start at the pharynx, because we've got here at the pharynx the back of the throat. Now the pharynx would lead on to clearly two tubes that we have. One is the windpipe and one is the esophagus, and the esophagus lies behind the windpipe. The esophagus will be our tube, or essentially to carry food, and the windpipe is the one that's going to allow us to transmit air for breathing. Now the windpipe is more scientifically known as the trachea. So it's just to be, I'm really making this starting point because on diagrams it sometimes can be quite confusing depending on the angle at which it's shown or drawn, which kind of tube, if you like, you're dealing with. But we're going to deal with the trachea, which is the windpipe. Now, there is this little flap called the epiglottis, found at the entrance of the larynx, where we have our vocal cords, and that's designed to actually prevent food going down the wrong way. So it makes sure that food goes down the esophagus and that none enters the trachea. So our story really picks up from the trachea. You can see that it extends down. And what isn't perhaps clear are these rings around, so I'm going to add this to the diagram. We have these rings of cartilage that line the trachea, and they're designed to provide structural support and to keep that tube open. So there's rings of cartilage give that trachea strength and allow it to remain open, gives it some sort of rigidity. So we have these rings of cartilage lining the trachea, which we can see branches into two. Now, not clearly shown by this diagram, but it branches into a right, because this is the right side of the body, this is the left. Similar when I in the video talk about the heart, we have the right on one side and the left on what you'd think would be the other. With the right bronchus and the left bronchus. Together they form the bronchi. And I'm just going to pick up on one of the bronchuses, or bronchi rather. So let's take the left one. If we extend the left one down, and in fact for this I'm going to shrink the screen a little bit. If we extend that left one down, so we have the trachea here. Here is the left bronchus. That would branch even further. Now I'm only drawing a few branches here. Like it's far more branched than what I'm showing. But you hopefully can get the idea that that bronchus will branch even further and give rise to smaller vessels known as bronchioles. So the bronchus will give much more divisions. It has multiple branches, each one called bronchioles. And at the end of each bronchiole, I'll draw a rough one here, you'll find these blue, they look a bit like cauliflowers. Those things in blue, which we call air sacs. Now each air sac is divided into multiple alveoli. So individual alveoli units form an air sac, and we have air sacs at the end, so at the terminal end of bronchioles. So just a bit of extra detail there. So we have the trachea coming down, branching to give a left and right bronchus. Those bronchus will give multiple divisions called bronchioles, and at the end of the bronchioles we get the alveoli. which form part of the air sacs. Now, single alveoli would be called an alveolus. We've also labelled in this diagram the left and the right lung. We've put the diaphragm in place as well, which lies just below the lungs. Diaphragm is a sheet of muscle, but not labelled on this diagram. And again, I'm going to come back and add a few more labels. Are these the ribs, which we know provide, in the first instance, protection to all our vital organs, especially our lungs, our heart, because the heart would be, not shown on here, but the heart would be located about here, where I've drawn an asterisk, slightly over to the left from the central position. Now, between the ribs, if I just draw one rib here and one rib here, between those ribs, you have what are called sheets of muscle. They're called the intercostal muscle. So this is intercostal muscle that you have between the ribs. Not shown very clearly on the picture. In fact, if I were to show it here, just by a few red lines. Now, inter means between. Costo was the Latin word for rib. So intercostal muscle is muscle between ribs. And you have internal and external intercostal muscles. I'll explain a bit more about the importance of those when we look at ventilation, but you have internal and external intercostal muscles between the ribs. And again, one thing not highlighted here is on the outside of the lung. So if that's, we'll label it up here. On the outside of the lungs, you have what are called pleural membranes surrounding the lung with pleural fluid running between them. You can just sort of make them out. They're the sort of yellow edge that you see running down here, and there's an internal one just around the purple shaded lung part. Those yellow parts are pleural membranes with pleural fluid between them. So here's our basic lung structure, our basic anatomy, if you like. Now, wouldn't be expected in school to label the entire thing, but certainly it would be important to recognise that the trachea comes down with rings of cartilage, branches into the two bronchi, which further branch into bronchioles, ending in the alveoli, and that they are surrounded by the ribs that have intercostal muscles between them. Now, those branches that we'll refer to, these bronchioles, they start dividing as soon as the bronchus sort of enters the lung. So those bronchioles are the passageways by which the air passes through the nose or mouth to those air sacs of the lungs, and there are branches that no longer contain cartilage or even glands in their submucosa. So they are specific branches of the bronchi. So as soon as the left and right bronchus essentially enters the lung tissue, they start to divide to provide these bronchioles. Now, interestingly, bronchioles are only about 1 millimetre, even less, in diameter. So very, very, very small, narrow tubes we're talking about here. Now, what I want to do is talk about ventilation, or the mechanism of breathing. My students often confuse breathing and respiration. The two are very, very different, and I want to explain what happens when we breathe in and when we breathe out. So I'm going to shrink this diagram down a little, just to make two sort of comparisons. So when we breathe in, when we inhale, our diaphragm contracts and moves down. That's the first thing. So our diaphragm, as labelled in the picture, diaphragm contracts, and when it contracts, it pulls downwards. Now the ribs, via the action of the intercostal muscles contracting, are forced up and out. So the intercostal muscles contract, and that would mean the ribs move up and out. So if you think of the thoracic cavity, and by thoracic cavity I mean the sort of region, what we call the thorax. So on our diagram we're talking about the region between my two red dotted lines. Our thoracic region, our main chest region, the volume of the thorax would increase if the diaphragm moves down. If we think of this like a jar, for example, a jar representing our thoracic cavity, if this base moves down, representing the diaphragm, and the sides, representing the ribs, move out, essentially what we've created is a larger space. So when the diaphragm contracts, pulls down, the ribs move up and out, the volume in the thorax increases. And because the volume increases, the pressure within the thorax falls. So because of that increase in volume, we get a fall in the pressure of the air inside the lungs. Now, because the air is at greater pressure outside of the body, so around the mouth if you like, than there is inside of the body in the lung, because there's more pressure outside than within the lung, by diffusion air will come in. Air is drawn in to our lung, into our respiratory system. And that's what happens when you inhale. When you inhale and the diaphragm pulls down, the intercostal muscles contract, forcing the ribs to move up and outwards. The volume increases within the thoracic cavity, so the pressure falls. And when the pressure falls, air is drawn inside the lungs and inflate. Now, when we exhale, it is almost the complete reverse. So let's just shrink the screen and think about when we exhale or seem to breathe out. Now, if this is the complete reverse, when we had the diaphragm contracting before, when we exhale, the diaphragm now will relax. And when the diaphragm relaxes, it will move back to its default position. It will move upwards. And equally, if the diaphragm relaxes, then what we have is the intercostal muscles relaxing, causing the ribs to move back down and inwards. So what was contracting before now relaxes. So if we have our diaphragm relaxing and moving, if we think of the jar scenario again, and we think of this as our thoracic cavity, if we have the diaphragm now moving back up, and because the intercostal muscles relax, we have the ribs moving back down and in, then you can see we're going to reduce the volume of the thoracic cavity. When the volume of the thoracic cavity reduces, that massively increases the pressure. So now our pressure within the thoracic cavity increases. Our pressure rises because the volume has fallen. So now the pressure in the thoracic cavity is greater than atmospheric pressure, as in the pressure outside of the body. And because air will move from where there's high pressure to low pressure, in this instance, we force or expel air out of the lungs deflate and push that air out, up the trachea, up the windpipe, and out of the mouth. So just to confirm, As you inhale, the diaphragm will contract and move down. The ribs will move up and out, thus creating a greater volume in the thoracic region. Because the volume has increased, the pressure that the gases are under inside the thorax reduces, so the pressure falls lower than that of atmospheric pressure, so air is drawn into the lungs and the lungs inflate. When we exhale, the diaphragm relaxes and moves to its default position back upwards. At the same time, the intercostal muscles will relax, causing the ribs to move back down and inwards, and the two things in conjunction will massively decrease very quickly the volume of the thoracic region. The decrease in the volume in the thorax raises the pressure at which the gases inside the thorax are under. Because the pressure now is greater inside the thorax than in the atmosphere, air is drawn out or expelled out of the lungs, out of the respiratory system, and the lungs deflate, and that ultimately is the mechanism of ventilation. Okay, I hope all that helps.